with the Commonwealth in London. So I think this initiative is going to feed in to some of the work that's going to happen both at Commonwealth level as well as nationally. And for us to have the Interaction Council as a very strong partner in this endeavor is so very important. And Dr. Jonas, through her position as the health advisor to the Interaction Council, has been creating that link for us. And I think going forward, we are looking at scaling up the work that we are doing, and maybe next year or the year after, working towards a bigger conference addressing these issues, especially with a focus on the digital solutions that are going to help us tackle or mitigate the climate crisis. So with those words, let me hand over to Dr. Jonas to do the formal introduction. I'm pleased that all of you from around the Commonwealth and beyond were able to join us. We look forward to interacting with you in our future deliberations as well. Over to you, Joe. You have to unmute yourself, Joe.
Right. Thank you. I'll start again. So a big thank you to Professor Vajira for making this partnership happen, and a welcome to all our participants as well. We're here in a moment. We've done a pre-recorded video link so that it can also go online as a series of YouTubes covering the main aspects of the report. So I won't speak too long for the introduction, aside from just saying a big thank you as well to our Gamma team, who you'll hear from in turn as they present the different aspects of the report going forward. The first video will be opening with my introduction, so you'll hear more from me shortly. Thank you.
Joe, hear you, please. So.
Report on digital solutions to address and prevent pandemics and to strengthen global health security. Welcome everyone to the launch of this report on digital solutions to transform the climate crisis and our planetary emergency. This is a collaborative initiative headed by the Commonwealth Centre for Digital Health and taken forward with a group of Sri Lankan digital health fellows as part of the Platform for Planet, Place and People. So this is part of a wider initiative. We've got a 5-year plan that was launched last year on digital futures, a platform for planet, place and people, as part of a global good. In essence, although set up by the Commonwealth Centre for Digital Health, these are digital tools and solutions placed on a digital platform, a website, that are fully accessible as open access solutions to help solve some of the world's most pressing challenges and problems. In our 5-year plan, last year, we launched a report on digital solutions to address and prevent pandemics and to strengthen global health security. A key part of global health security, though, is in essence about how we respond to the climate emergency. And in our 5-year plan, the next slide here, at the top of the left-hand slide, you can see there's a world circle with a first aid symbol. And in essence, this is what we're addressing in this year's challenge. And it's been a great challenge with our digital fellows, is how we enhance and make available digital solutions for our climate emergency and planetary crisis. So, and it's part, just to convey, this is part of something that's a much bigger initiative of the Platform for Planet Placing People, and we're addressing particularly the planetary health component. So, to the report itself, as I said, it's on digital solutions to transform the climate crisis and our planetary emergency. We're a unique group of medical doctors with skills in public health and also in digital solutions. So we've brought together a very unique report. So the first part of the report that I'll introduce is essentially a medical perspective on the planetary emergency and thinking about the vital determinants of life. We'll next hear from our fellows on the climate emergency or the climate crisis, followed by digital solutions for the climate crisis in generic, not just on health solutions, that also address the planetary emergency. So this will look at the history of digital solutions as well as existing digital solutions. Then the next section will be a presentation on the future challenges and opportunities presented by digital solutions to transform our planetary emergency. And as part of that, we have a concept that we'd like to present and share with you on developing a global index for the vital determinants of life, before I then close with recommendations to advance with partners. Our planetary emergency and the vital determinants of life. So here we'll hear about the planetary emergency and the concept of the golden hour, the vital determinants of life on this earth, as well as why we need an emergency response to address our planetary emergency. So firstly, as medical doctors, we have a unique perspective on health. And we think about the health of the whole organism or the whole body. So looking at the health of the planet, we think about the whole health of the planet. And if we were to consider the life system of the planet, we would be seriously concerned. If patient planet were to walk through our clinic door, we would immediately see as doctors that there's a failing respiratory system, there's difficulty breathing, there's circulatory collapse, there's multi-system organ failure. We would just be able to see straight away, and many of us can now with the planet's health, that it's in a critical state. We wouldn't hesitate. We would send patient planet straight to intensive care for urgent treatment. Moreover, that urgent treatment has to be taken forward in a critical place and time. So we can call this the golden hour. In medical terms, the golden hour is the magical hour that you have to be able to save somebody's life. If they've had a car accident or if they've had a heart attack, that first hour is very critical. The Earth is in its golden years. We may have 3 or 5 years that we can call the golden years of the planet, where we really have a unique period of time where we can intervene and prevent the collapse of the planet's systems as we enter different tipping points. So going forward, we can make analogies with the planet's health with the vital determinants of life on Earth. So this next slide illustrates the 9 planetary boundaries. Good work taken forward by the Stockholm Resilience Centre that have illustrated how the planet already has exceeded different boundaries for life on this planet, for humans. Going forward, we could take that analogy further. As medical doctors, we've looked into the analogies of what are the generic features, the vital determinants for all forms of life on this planet. And I highlighted those as the ABC of the vital determinants of life. So there's air, water, food, and land. Land, in essence, is what we live on, the infrastructure, and it's equivalent to maybe our skin or our muscles and bones. You need something to live on or to live in. We also supported all life systems, whether they're human or the life system of the Earth, have different principles or core components that actually enable the stability of a place to live. The stability is often called homeostasis, where you get a balance constantly to make sure that it's a stable environment to live in. We also have different mechanisms to transfer energy, which we call kinetic transfer. We have mechanisms to clear our toxins as well. And furthermore, we have approaches to protect ourselves and develop immunity to protect ourselves from invasions and infections. Additionally, we all have the ability to reproduce and ideally to diversify, to adapt to different environments. And lastly, virtually all life forms have some sort of intelligence or a way of communicating with other forms of life. So this is what we've come up with, the essential life functions and the vital determinants of life, as a way to think about how we can transform and utilize digital solutions going forward to contribute to the climate crisis and planetary emergency. When we think about the Earth's temperature and the Earth's temperature chart, we can see as one key indicator that we're in a critical state. Although we know that the Earth can fluctuate in its temperatures across days and years, maybe from -50 to +50, on average, we as humans in our span of history have only lived on planet Earth for temperatures ranging from -1 to +1. You can see it's been a very stable environment for life for humans on this Earth. And even though the Paris Agreement is saying that it's safe to go up to 1.5, you can see that already, even at 1.1, we're experiencing significant changes that are challenging already for humans. As we go on up the temperature scale, 2 degrees, 3 degrees, 4 degrees, you can see that there will be serious changes and that will severely compromise our ability to live on this planet. The analogy is with a human or other mammals. They have to have very stable temperature environments to live. And in fact, 4 degrees is enough to kill a human. So we need to take very seriously these early changes in temperature and how that can destabilize life forms. So even at 1.5 degrees, there's the risk of tipping points cascading and causing further rises in temperature. So this is a critical measure for the Earth's temperature. So going forward, we need an emergency response for our planetary emergency. We've taken many, many years to work out where we've got to, what the problems are, to try and identify how to solve them. But we're running out of time and we need to take an emergency response. we've outlined in this report, based on learning that we already know and on systems that we already have access to, how to prevent, how to prepare, how to respond, how to recover, what enablers already exist, like governance, knowledge systems for risk management, how we build resilience, and how we strengthen capacity. But we have to act now, and we have to act urgently. The World Meteorological Office predicts that even within 5 years' time, the average temperatures of this planet may have reached 1.5 degrees. We are truly in the golden hour of this planet. Although we're in a critical situation, I believe that we have technological solutions that can help us to overcome these challenges. And I believe that digital solutions can play a key role in that. Not that dissimilar to catalysts or enzymes in life systems. That actually, if we utilize tools in key ways, we could actually help to transform the future of our life on this planet. This slide illustrates how we could create a global emergency platform for people and planet. We could utilize knowledge from health systems to think about a comprehensive One Health systems, essentially multi-sector systems. We could create global goods based on digital solutions to actually deliver the different services needed for governance, knowledge, advocacy, capacity, and across the system actually transform the way that we address these challenges. Going forward, there are real opportunities as well with AI solutions in terms of how we can actually enhance risk analysis and develop different scenarios. But digital tools in themselves can act as key levers to scale and speed up our response and to act in collaborative ways.
It's now time to hear more from our Commonwealth Digital Health Fellows, who will take it in turn to present the different sections of the report that they worked on and developed over the course of this last year. However, we did develop this collectively through regular team meetings as well. So it's with great pleasure I'd like to introduce Dr. Janica, who will be talking us through the climate crisis. Thank you.
Thank you, Dr. Joe.
So whilst we're just waiting for the video to upload, is it good?
No, that's all right. I'll
Brilliant.
give me a second.
Thank you.
Has changed. The mixture of gas is shifting with more and more greenhouse gases like carbon dioxide, and this shift is happening fast each year. Concentration of CO2 has reached level never before breathed by humans since Homo sapiens sapiens evolved. In just 100 years, eons of fossil fuel sunshine have been burned as coal, oil, and gas. The exhaust has transferred the entire atmosphere and ocean. It is like pollution blanket, and the result we know as climate change. So how much of fossilized sunshine can we burn before further destabilizing the Earth system? Well, not much. Think of it as a carbon budget. We are currently adding 55 billion metric tons of greenhouse gases into the atmosphere every year. This is gigaton challenge. By some estimate, at that pace, we will have burned throughout the remaining budget by the year 2030. So, to give us some room to breathe, the world must reduce greenhouse gas pollution by more than 7% each year, every year of this decade. According to the prediction, if we cut down CO2 by 7.5% in 2030, the emission of CO2 would be 55 gigatons, and the surface temperature would be 2.7 centigrade, which is too high. Or if we cut down CO2 by 30% in 2030, the emission of CO2 would be 39 gigatons and the surface temperature would be 2 centigrade. It is just aligned with the Paris Agreement, but the diverse ecosystems might get affected and there will be a direct impact on biodiversity. But if we go for 55% reduction of CO2 emission on 2030, we are emitting 25 gigatons of CO2 to the environment. The surface temperature would be around 1.5, and that would be ideal for plants, animal, and human beings. But this is challenging. CO2 has a long life. Once it is added to the atmosphere, it can stay up there for hundreds of years, even longer. CO2 emission must be cut half by 2030, then reduce even further by 2040 to put the world on a path of adding no more CO2 to the air by 2050. And then that means transforming the modern world and quickly as possible. Greenhouse gases like CO2, methane, nitrous oxide make up the bulk of the climate challenge. All must be reduced fast. There are other greenhouse gases like water, CFC, ECT. Some of them are natural products. By any chance, if we do not have the greenhouse gases, the surface temperature would be 18 centigrade or below. But on the other hand, if we produce more greenhouse gases and exceed the safe level, the surface temperature will increase. The global CO2 emission is high in countries like China, United States, India, Russia, and Brazil. They emit large number of CO2 into the atmosphere. But per capita CO2 emission is high in countries like Middle East, Canada, Saudi Arabia, US, Australia, New Zealand, Russia, South Korea, Japan. This is due to relatively low population compared to the countries like China and India. The majority of modern energy comes from fossil fuel, which make the energy sector 76% of the climate change, including fossilized fuel used for transportation, industrial process, and agricultural product. The shifting to clean energy must be accelerated by an order of magnitude if we want any chance to restrain global warming to 2 degrees, preferably 1.5 degrees. This will lead more ways to store this clean electricity, whether that putting it in the chemical bonds of a battery or in a molecule of hydrogen. Batteries and clean hydrogens are also going to play a key role in cleaning up transportation. This 17% of climate change pollution include the uses of energy to move people and goods, around 8% from the cars, 5% from trucks and other heavy-duty vehicles, and 4% from the ships and aviation. The complete green energy does not exist. Whenever human acts and create a solution for green energy, it might create environmental pollution. With abundant clean electricity, the world can win the race to electrify cars and create cleaner alternative fuels for trucks, ships, and even one day aeroplanes. We will find classical rare metals like gold, silver, tin, palladium. There are more exotic rare metals like europium, samarium, gadolinium. These rare metals, which has physical and chemical characteristic to run electric vehicle, but once it's gone, it's gone. Mining and water table. Some mine consumes almost 2,000 liters of water per second. Much of the wetland and groundwater is literally absorbed by the large mining industry. The untreated wastewater with heavy metals and toxic acid discharged into the water will end up by causing ocean acidification and may lead to catastrophic events.
The air we breathe has changed. Literally absorbed by the large mining industry. The untreated wastewater with heavy metals and toxic acid discharged into the water will end up by causing ocean acidification and may lead to catastrophic events of biodiversity. The untreated wastewater discharged from the factories causing torrents of black water saturated with acid and heavy metals such as chlorine or mercury. Wastewater from the production of rare mineral infiltrate the soil. When people get their drinking water from the water table, it damages their health. There are radioactive elements which infiltrate the soil with wastewater and diffuse slowly by causing radioactive contamination. Methane is better at trapping sun's heat, which means cutting methane pollution is a necessary and fast-acting stimulus for our carbon budget. It means emission from agriculture and the oil and gas industries can be eliminated in the decade. We might be able to stave off catastrophes like the loss of Arctic sea ice. There is also nitrous oxide known as laughing gas, but it is no laughing matter. N2O is about 300 times as potential as carbon dioxide at heat in the atmosphere. Like CO2, it is long life spending an average of 114 years in the sky before disaggregating. It also depletes the ozone layer. The climate impact of laughing gas is no joke. Since at the Intergovernmental Panel on Climate Change, IPCC, have estimated the nitrous oxide compression roughly 6% of the greenhouse gases emission, and about 3/4 of the nitrous oxide emission comes from the agriculture. But despite it is important contributor to the climate change, N2O emission have largely been ignored in climate policies. The gas continues to accumulate. Experts say nitrous oxide increased 30% in the last 4 decades in agriculture soil, especially because of the global heavy use of synthetic nitrogen fertilizers is the principal culprit. Then there are our lifestyle and the material needs to be modified. That's everything from the cement, steel that go into buildings to the plastic, fibers, and even more than in fashion. These materials account for 6% of emission on top of the energy emission required to produce them, and we need new and clean ways to make them or replace it. Farming and animal raising also have to change, as agriculture accounts for 12% of greenhouse gas pollution. That means everything from how and what people eat and how and what cows, chickens, and pigs are eat to be changed. It also means finding a ways to farm fields to go from sources of greenhouse gases to places where greenhouse gases get buried. Truly solve the climate change, the world will have to be protected and restored to allow all of life, marine forms to flourish. Halt in cutting down forests, burning peatland, and converting coastal wetland could prevent the release of nearly 5 billion metric tons of greenhouse gases each year by restoring nearly 200 million hectares of degraded forest. Land, peatland, and wetland could also absorb almost another 4 billion metric tons. Perhaps even more important than the ocean has vast potential to help reduce greenhouse gases if we protect it. There are technologies being developed to draw down CO2 from the atmosphere because we have already emitted too much. But very few of these machines from us have been developed, and they are too expensive to scale up faster right now. This is the climate challenge we face, going from adding 55 billion metric tons of greenhouse gases to the air each year to add zero emission by year 2050. Slide 18. It is amazing progress that from 2015 to 2030, we have this global agenda or the global framework which was adopted at the United Nations World Conference in Sendai, Japan. There were 3 frameworks emerged: Sustainable Development, Paris Climate Agreement, and the Sendai Framework for Disaster Risk Reduction. Our action ultimately failing under these main 3 key pillars within the territory of development, peace building, humanitarian action, and climate change. It was also a real significant milestone in 2016 to need of review how we do humanitarian aid to try and shift from response to prevention. Paris Agreement, the temperature target estimated in the Paris Agreement aims to limit global warming well below 2 degrees, preferably 1.5 degrees Celsius compared to the pre-industrial level, compared to the Earth's average temperature in the late 18th century. Sendai Framework. In order to reduce disaster risk reduction, there is a need to address existing challenges and prepare for further onset of focusing more disasters, which need monitoring, assisting, and understanding the disaster risk and sharing such information and on how to create or strengthen the mitigation process. This will include the economical, social, cultural, and health aspects in order to mitigate or prevent the loss and damage is a key component in Sendai Framework, which will able to calculate the losses and damage. Sustainable development goals are global goals are the collection of several interlinked objectives designed to serve as a shared blueprint for peace, prosperity of the people and the planet now and in future.
Thank you very much for listening to my presentation.
Thank you, Dr. Janica. It was a really helpful overview on the, sorry, we've just got some noise in the background. A really helpful overview on the climate crisis. We've heard about the planetary emergency. We now want to move on to what can we do about it and how digital solutions can actually help us solve some of these really phenomenal global challenges. So I first like to hand over to Dr. Nirmala, who will introduce chapter 3, including the methodology. Essentially, it's describing a review that was conducted by our Commonwealth Digital Fellows on what digital solutions already exist now. And it also provides an historical context, as you'll see. After Dr. Nirmala has presented, we'll hear from Dr. Zayed, who will outline the main results from this review. So I'll hand over now. Thank you so much. Oh, sorry, are we ready to go?
Yeah, sure. We are ready to go.
Brilliant. Thank you.
Digital Solutions for the Climate Crisis and Our Planetary Emergency, Chapter 3. Since the introduction of computers and digital software tools, they have immensely contributed to the progress of the humankind. They basically have transformed the way we communicate, work, learn, and create. Digital software solutions have played a pivotal role in driving the progress and promoting innovation and driving socio-economic development in the global community. Climate change management is a field of practice in which digital solutions have made a significant positive impact. As a data-intensive discipline, climate change management has integral requirements for efficient data processing, visualization, modeling, collaboration, policy development, and information access. Digital tools have contributed to enhance decision-making, to promote collaboration, and to facilitate effective actions to address the challenges imposed by climate change. With this background in Chapter 3, we wanted to answer some important questions related to the use of digital software tools in climate change management. They are the basic objectives of our Chapter 3. These objectives are to identify and acknowledge the role played by digital tools in climate change management, to identify different categories of digital tools associated with CCM, to align these categories of tools according to the enablers of emergency response, to describe the historical evolution and the foreseeable future of these digital solutions, and to identify potential open access global digital goods in CCM. So to answer these questions, we took the following path. This is our methodology. We made searches for publications in Google search engine, Google Scholar, Science Direct, Web of Science, and other related search engines. A combination of keywords were used to identify content up to the year of 2022. And over 150 journal and web publications, websites, and mobile apps were assessed. Findings are presented in Chapter 3 in the following sequence. Next set of slides showcases the answers to some of the questions presented earlier. During the study, we were able to categorize digital solutions in climate change management into 9 broader groups, where some groups have overlapping features. Data management analysis. They provide tools to facilitate the entire data lifecycle of climate change data. Carbon accounting and emissions management. They provide tools to monitor, quantify, and manage greenhouse gas emissions. Climate change modeling and simulation. Providing tools to develop the data-driven models and simulate and predict future scenarios. The next category, environmental monitoring and remote sensing. Providing tools to utilize data from satellite systems and remote sensor systems climate communication and engagement, providing tools to facilitate the communication of climate change related information, awareness campaigns, and stakeholder engagement. Next one is renewable energy planning and optimization. They provide tools to assess renewable energy resources. Climate risk assessment, the next category, providing tools to assess the vulnerability of communities, infrastructure, and ecosystems to climate change impacts. Adaptation, planning, and early warning systems are the next category, where they provide tools to development of adaptation strategies and risk management plans. Last but not least, online learning and education tools for the development of human abilities and skills, including massive online open access courses for education, training, and professional development. Then we were able to map these solution categories into the emergency response enablers discussed previously in chapter 1. During the study, we also were able to graphically represent the general trends in historical evolution of digital solutions used in climate change management. This diagram shows the limited number of tools available in the early period of computing. With the growth of technology, where there's more computational power and introduction of personal computers and World Wide Web, you can see the growth of the range of tools available for climate change management. And their features were also growing, and the user base also seems to grow. And at last, we have spoke about the future of digital tools with the advance of technology, including AI, quantum computing, and other related new technologies. For the rest of the finding of the chapter 3 will be presented by Dr. Siad. Over to you, Siad.
Thank you very much, Dr. Joe. As Dr. Nirmala explained, we have found several digital solutions or goods for the climate crisis in our planetary emergency. We have categorized them as governance, knowledge, capacity, advocacy. So let's briefly see what are the solutions available with some examples. So first, let's see the governance. So we have categorized them in a table. So this table has the categories and the tools. Tools mean what are the solutions available with the web links and the year of release and the architecture, whether it is a web-based, cloud-based, or standalones, and the licensing, whether it's a free and open source or the paid one, and the geographical coverage, whether it is a local one or the regional one or the global one. So when you see the governance, it can be divided into two parts. One is the data management and analysis. It has several tools like CEDA architecture. I will explain what is that. And the Climate Explorer, Climate Data Store. And there you can see these items in the links we have provided. And in the carbon accounting and emissions management, there are greenhouse gas protocol, full climate calculator, carbon footprint calculator, and carbon climate registry. So let's see the CEDA architecture. The CEDA architecture forms a part of Natural Environment Research Council's Environmental Data Service and is responsible for looking after atmospheric and Earth observation research data. It hosts over 80 petabytes of data from climate models, satellites, aircraft, met observations, and other sources. When you see the carbon accounting and emissions management part, there's a protocol called GHG, that is Greenhouse Gas Protocol. It's a comprehensive global standard framework to measure and manage greenhouse gas emissions from private and public sector operations value chains, and mitigation actions. GHG protocol supplies the world's most widely used greenhouse gas accounting standards. The tools enable companies to develop comprehensive and reliable inventories of the GHG emissions. So you can click the link and see the details. So when you come to the knowledge part, again, we have categorized them into two. The first category is climate modeling and simulation. So there are several solutions available like MIT Integrated Global System Model, Weather Research and Forecasting, Cosmos CLM, ClimatePrediction.net, Community Earth System Model. Also, the knowledge part divided into environmental and monitoring and remote sensing. Here, there are so many tools available like land cover classification systems, Google Earth Engine, Collect Earth, Global Forecast Watch, OpenAQ, SWAM, that is Smart Water Management Product, and eReefs. So let's see the couple of examples of both of them. So one is the climate modeling and simulation. Here we can see the website called ClimatePrediction.net. Actually, it's a volunteer-based one using computing climate modeling project based at the University of Oxford in the Environmental Change Institute. Actually, they run climate modeling experiments using thousands of volunteers. This allows us to answer important and different questions about how climate change is affecting our world now and how it will be affect our world in the future. So you can click the link and see the details further. So another web solution is the Global Forest Watch. It's an online platform that provides data and tools for monitoring forecasts by harnessing cutting-edge technology. GFW allows anyone to access near real-time information about where and how forests are changing around the world. So the next category is capacity. So the capacity also we have divided into two types. One is the renewable energy and planning optimization. Here there are several tools like Homer, Osmosis, OpenEI, Switch. Most of them are globally available. And also climate risk assessment and adaptation. It is including National Oceanic and Atmospheric Administration, Pacific Disaster Center, European Food Awareness System, Global Disaster Alert and Coordination, Sahana Disaster Management System. Some of them are regional one, some of them are global one. You can visit by clicking the links. So when you see some example from them, the first one is the Explore Open Emerging Information Data and Application on OpenEI. The OpenEI is developed and maintained by the National Renewable Energy Laboratory with funding and support from US Department of Energy and network of international partners and sponsors. OpenEI is also host to many applications that may be used to exploring data and empowering the industry to make informed decisions. Another example for climate risk and assessment and adaptation is GDACS. It's a cooperation framework between the United Nations and European Commission and disaster managers worldwide to improve alerts, information exchange, and coordination in the first phase after major sudden onset disasters. So you can visit this website and see the details and alert messages. And the next category is the capacity. In the capacity, you can see climate risk assessment and adaptation. There are so many tools available like Integrated Public Alert and Warning System, INVEST, Pager, Agroclimate, En-ROADS, Africa Risk View, the Extreme Rainfall Detection System, Distant Early Warning System for Tsunamis, Servers, Fresh Flood Early Warning System. Most of them are open source and globally available. You can visit them. Let's see one of the example of that. That is called INVEST. It's an integrated valuation of ecosystem services and trade-offs. It's suited for models used to map and value the goods and services from nature that sustain and fulfill human life. It helps explore how changes in ecosystems can lead to changes in flow of many different benefits to people. So the final category is the advocacy, where you can see the climate communication and engagement. The tools like Climate Interactive, Skeptical Science, Climate Central, Climate Feedback, Climate Visuals. Most of them are web-based and openly available for global use. So when you see the Climate Interactive, is aimed to synthesize the technical climate science into accessible mediums and harnesses to power up experimental learning to engage and inform people about high leverage, equitable climate solutions. So there, other than this web and standalone solutions, there are so many mobile apps available for climate change management. So we have selected some most important solutions like Carbon Tracker, Climate Clock, Jolubug, iNeutralist, Earth Now, Global Forest Watch, Ecosia. All these platforms are available iOS and Android. You can download and use it. So let's see one of the example of that. That is called iNaturalist. It's one of the world's most popular nature apps. iNaturalist helps you identify the plants and animals around you and get connected with a community of over 1 million of scientists and naturalists who can help you learn more about the nature. So what's more, by recording and sharing your observations, you will create research quality data for scientists working for better understand and protect nature. Actually, this iNaturalist is a joint initiative by California Academy of Sciences and National Geographic Society. Also, we have done some case studies. We have included some case studies like solution for diverse geographies and diverse domains. Its integration of an array of diverse digital technologies into a single solution platform, and also covering both climate change adaptation and mitigation. So here we have displayed the location of these case studies found in the internet. You can read the main document to see the case studies. So this is my simple presentation on this digital tools available for this climate change. Thank you.
So thank you, both Dr. Zayed and Dr. Nirmala. This review, which consists of the sort of bulk of the report actually, and the resources, the open access resources, will also be put online for the platform Planet, Place and People. The purpose was really just to see what's already out there, what's existing in this space that can help us in the here and now in terms of addressing some of our climate challenges and also around the sort of natural world in terms of the planetary emergency. So firstly, you can see that there's already quite a lot out there, whether it's targeted for individuals or national level, regional level or global level. But having conducted this review, it's also possible to see where there's gaps and where there's opportunities to develop further from case studies that might be at local or national level that could then become global tools. So that gives us hope for the future, and there's many opportunities you can see and much innovation in this space. And the platform for Planet, Place and People, the intention is that putting them all in one place helps it become a go-to place that we can then also help further collaboration and coordination that influence policy making and decisions, because that's where the other key gap is. There's a lot happening in academia, but it's not significantly influencing and shaping a global strategic response. Now, what we can see over the last few years is that we have essentially an escalating planetary emergency. But we also, whilst we were conducting this research and the reviews, it was all during the time of emerging technology and the threats from AI, artificial intelligence. So our group has had many discussions actually about what are the future risks and opportunities of digital solutions in the next few years, and what's the convergence of this in terms of addressing our planetary crisis. So we'll next hear from Dr. Krishantha, who undertook the chapter and is now going to present to us on essentially future digital solutions. And it gives the context historically, as well as where the kind of key opportunities lie in the future. So thank you, Dr. Krishantha.
Thank you, Dr. Joe. Chapter 4 is about the future of digital solutions, climate crisis, and planetary emergency. Before we talk about the future, let us briefly reflect on the history and the evolution of digital solutions as well as the climate crisis. It was widely believed that prior to the Industrial Revolution, humans had a few basic needs and therefore led an environmentally friendly lifestyle with minimal harm to the planet and its ecosystems. However, with each stage of the Industrial Revolution, our needs and lifestyles grew increasingly complex. We started utilizing Earth's limited resources more extensively, leading to escalating environmental pollution and ultimately resulting in the current climate crisis, which we now face as a global emergency. The first industrial revolution, believed to have occurred around 1760s in the 18th century, was primarily driven by the discovery of steam and hydropower driven engines and mechanics. In the second industrial revolution, or the IR2, took place more than a century later than the initial, around 1870 in the 19th century. This revolution was mainly characterized by the mass production of human necessities through electricity-driven processes. The third industrial revolution, or the IR3, happened somewhere around in the 1960s of the 20th century, just about 100 years after the IR2, marked the arrival of digital solutions and the binary era, and was preliminary propelled by the automation of mass production through computers and robotics. After that, the fourth industrial revolution, or the IR4, came relatively quickly, just about 30 years after the IR3, around the year 2000. The very beginning of the 21st century. This revolution was mainly driven by the data sciences, the internet, and the mobile technologies. As evident, the time gaps between these industrial revolutions have been narrowing down, and now we are entering a rapidly transforming era of a fifth revolution, being driven by big data, leading to artificial intelligence and highly advanced robotic systems. But here is the problem. Even though we are in the era of a fifth revolution, we still rely heavily on the fossil fuels that have been using since the first revolution, as shown by the bottom pink arrow. The small green arrow represents the recent trend of sustainable energy sources. But this is the real world scenario of the above two arrows. As you can see, since the third digital and binary driven revolutions around 1960s, the human global energy demand, or the consumption, has also been increased very rapidly. That very high, continuously rising energy demand, still about 95% relies on non-sustainable or non-renewable energy sources, like fossil fuels such as coal, crude oil, natural gas, and traditional biomass like wood, which was rapidly depleting since the first revolution. Although there is a growing trend, still only a tiny portion of the world's energy needs comes from sustainable or renewable sources like solar, wind, hydropower, etc. We rapidly need to find ways to use and store sustainable energy sources because our demand for energy keeps growing. Also, it's important to reduce our energy needs while finding the ways to meet them with sustainable sources. Next, we will explore important keywords and trends that can enhance our understanding of the future of digital solutions. Multidisciplinary digital solutions. Multidisciplinary digital solutions are approaches that combine different areas of expertise to tackle complex problems using digital technologies. These solutions are built upon key pillars such as data science, ecology, health, engineering, social sciences, and politics. One area where multidisciplinary models are crucial is in addressing climate change and related environmental and health issues. Given the interconnected nature of these technologies, a multidisciplinary approach becomes an essential tool. Big data. Big data refers to data sets that are too large or complex to be managed using traditional data processing methods. It is extensively used to study climate change and its impacts, as well as various issues in other sectors. Analyzing big data poses several challenges. These include capturing the data, storing it efficiently, analyzing it effectively, searching for specific information, sharing and transferring it securely, visualizing the data, querying it for insights, ensuring information privacy, and identifying reliable data sources. Dealing with big data requires significant computing power and storage capacity, which is why big data centers are essential. However, it is important for these centers to adopt green and sustainable solutions to minimize their environmental impact. By embracing eco-friendly practices, these big data centers can contribute to a more sustainable future. AI or the artificial intelligence. Artificial intelligence refers to the ability of machines to perceive, synthesize, and infer information similar to how humans or animals do. It enables machines to perform complex tasks and make decisions based on data and algorithms. One significant advantage of AI is its ability to simplifying big data analytics. By automating intricate analytical tasks, AI streamlines the process of extracting insights from large and complex datasets. AI can also be used to gain a better understanding of climate changes and planetary emergencies. It has the potential to analyze vast amount of data, identify patterns, and make predictions about future scenarios. This can aid in developing new and improved solutions to mitigate the impacts of climate change and address planetary challenges. Quantum computing. Quantum computing is an emerging field that combines computer science, physics, mathematics, and quantum mechanics to solve complex problems faster and more efficiently than traditional information and communication technologies. One of the existing possibilities of quantum computing is its potential to accelerate the discovery and development of new green computational technologies. By harnessing the power of quantum systems, researchers can explore innovative approaches for sustainable energy production and storage. This can lead to advancements in renewable energy sources and more efficient methods of addressing climate change. Furthermore, quantum computing offers the potential to enhance strategies for climate change mitigation. Its computational capabilities can aid in simulating and modeling complex environmental systems, helping us better understanding the impacts of climate change and develop effective strategies to mitigate its effects. Collaborative digital tools and future platforms. Collaborative digital tools and future platforms are essential for addressing the challenges of climate adaptation and mitigation. A lack of collaboration can be a significant barrier in tackling the climate crisis. To effectively combat the climate crisis, it is crucial to have global, regional, and national governmental collaboration in both technological as well as political aspects. Working together, these entities play a key role in implementing strategies and solutions to fight against climate change. Digital tools and platforms facilitate interaction and collaboration among multiple partners. By using these tools, organizations can enhance innovation and create new solutions to complex challenges. These platforms provide a space for collaboration, idea sharing, and coordination, enabling stakeholders to work together more efficiently. The COVID-19 pandemic has accelerated the development and application of digital tools for collaboration. The need for remote work and virtual communication has pushed the advancement of these technologies. As a result, digital collaboration tools have become increasingly accessible and user-friendly, enabling effective collaboration even when physical proximity is not possible. Future risks and governance requirements. In the future, there are risks associated with the use of new technologies and collaborations. While these novel systems can have positive effects, they also have the potential to be used in ways that can harm society and the humanity. It is important to ensure that the risks associated with these technologies are manageable and do not have a negative impact. To address these risks, it is crucial to establish a global governance framework. This framework will help to minimize both current and future risks. By developing and adopting this framework, we can effectively manage the potential negative consequences of new technologies and collaborations. It will provide guidelines and regulations to ensure the responsible and ethical use of these innovations, safeguarding the well-being of society and human as a whole. We are currently in the era of rapid transformation of the fifth industrial revolution, where technologies like big data, AI, and potentially quantum computing are shaping our future. These digital solutions have surpassed human capacity to handle big data and resulting big information, big knowledge, and big intelligence. They are also gaining more and more ability to make decisions and even replicate themselves. However, it's important to note that the majority of these digital solutions still rely heavily on fossil fuels as their primary energy source. While digital tools offer solutions, they can also contribute to the challenges we face with the climate crisis and planetary emergency. Therefore, it is our responsibility and duty to ensure that these digital solutions are directed towards a more sustainable manner, and it is crucial to harness the potential of digital solutions to mitigate the negative impacts and create a more sustainable future for everyone. It's our wish the next sixth industrial revolution will be a sustainability-driven solution within the near future, pursuing the planet Earth for the future of all living things in our ecosystem. Thank you.
A big thank you to Dr. Krishantha. A very inspiring presentation about how we need to proactively and strategically shape our future. A lot of the discussion you're probably aware of on artificial intelligence and emerging technology in the last few months has been very much about the risks, about what governance we need. And clearly we need to manage the risks, but we also need to see where the opportunities lie, and not just to hold back technology, but to actually direct technology so that it can shape our future in a positive direction. We see for the synergies of emerging technology and the need to rapidly address our planetary emergency could be very, very beneficial, not only in terms of managing and identifying risk with things like big data and sort of rapid analysis, for example, of different scenarios with quantum computing coming online, but also the ability to take a more multidisciplinary approach to some of our challenges going forward. As with many areas, the climate challenge has taken a siloed approach to individual risks for tipping points, for example, but actually we know that they interact and they often reinforce each other. Ultimately, what we're proposing is that we understand the planet's life system as a complete and comprehensive system in a very similar way to how we understand health systems in terms of the human body. So building on these analogies and across our discussions and the opportunities that we could see with the development of further digital solutions going forward, our fellows came up with the concept of developing a global index for the vital determinants of life. So this builds on other initiatives, as we'll hear in a moment from Dr. Deepal, who has particularly advanced this initiative. And I just want to really emphasize this is still a concept at the moment, but I think with different partners, it could act as a tool, as a digital tool that actually helps bring together much of what we have in this report, for example, builds on other initiatives and other partnerships. And it could act as an index that monitors the state of the planet's health and helps identify priorities of where we need to intervene, but also it could help us guide us to identify strategic solutions so that we can act effectively in terms of bringing about a healthy planet for all of us to live on. So with no further to do, I want to hand over to Dr. Deepal. Thank you so much.
Thank you, Dr. Joe. Before starting my presentation about GIVDL, Global Index of Vital Determinants of Life, I like to draw your attention to a small video clip. Let's see it now.
Picking up the analogy of the golden hour again, it is vital that such golden years as remain before we should be used wisely. To secure the survival of future generations, we need to generate an emergency response in order to stabilize the Earth's health system. In an emergency situation in animals, vital life signs are determined by the ABC of airways, breathing, and circulation equivalent to Earth's air and water systems. In intensive care, the functions of the major organs need to be maintained and sustained to prevent multi-system failure. In the analogy, this equates to food, while land represents the skin with the final stages of systemic shock observed just before death. Air, water, food, and land, or a place to live, can be seen as the essential determinants for all life forms. These essential determinants of life is named as vital determinants of life. These build upon existing evidence including that from the Drawdown Project, the Lancet EAD Commission, Nature-Based Solutions, Planetary Boundaries, and NASA's vital statistics for the Earth.
As you seen in a video, it is a concatenation of previous chapters and a reinforced relationship between planetary health and human health. With this background, let's discuss our GIVDL. Our proposed global index of vital determinants of life is an analogy to multiparameters used in ICU patients to detect changes in vital signs. Planetary health needs a tool analogy to multiparameter in ICU. We proposed the global index of vital determinants of life as a tool analogy to multiparameters. GIVDL, the global index of vital determinants of life, is based on 4 vital determinants of life, namely water, air, land, and food. We have to find suitable indicators which represent the global condition of each VDL. One of the sources to find representative global indicators for VDL is indicators used in planetary boundaries. Though planetary boundaries are novel concepts and still evolving, there are global climate change indicators that are successfully adapted in current global decision making. Our suggestion is to use representative indicators which are already used in global climate change to create GIVDL. We have managed to find 14 currently used indicators to represent in 4 determinants of life. As shown in the slide, there are 6 indicators for water, 3 indicators for air, 3 indicators for land, and 2 indicators for food. As we discussed the concept of GIVDL, Global Index of Vital Determinant of Life. Now I am going to summarize key features in this slide. As you know, it is a synology to vital sign monitor. In human health, it consists of 4 components of VDL, and each component is determined by the identified global indicators. Currently, we propose to use indicators in a well-being of planetary boundaries. Those indicators are global level indicators of each VDL. However, each global indicator is determined by the country level contributions made by individual countries. An individual country's contribution is dictated by multiple contributory factors unique to that country. Therefore, each country should have a mechanism to identify, plan, implement, monitor, and evaluate priority intervention based on their contributory factor landscape. Data should be entered at the country level for each indicator, which can be summarized at the regional and global levels. The average of individual indicator determines the value of individual vital determinants of life. The data entry form is designed based on 7 parameters. These parameters represent governance, strategic alignment, financial commitments, and the workforce of representative country. The final score for the indicator is between 0 to 5. The final score for each determinant of life is calculated by all the indicators belongs to relevant VDL. It is basically the average value of all the indicator values. Finally, our proposed GIVDL, Global Index of Vital Determinants of Life, is a tool to measure the status of planetary health at a glance. It is an analogy to multi-monitors used in ICU. However, GIVDL's intended purpose strongly depends on the indicators used to calculate the value. Therefore, subject experts should continually research to find the best indicators for GIV. We proposed those indicators should be periodically updated according to the change in planetary health landscape. Thank you.
Thank you. Thank you, Dr. Deepal. We're now going to move to the recommendations. And as we're running a little short of time, I just want to invite, if anyone needs to leave early, do get in touch with me and I can follow up individually as well in case you'd like a further chat about this. Thank you. And now to the recommendations that we would like to advance with wider partners. So on the left-hand side, I've highlighted a list of recommendations that could be taken forward in the short term. They include strengthening governance for existential threats and risks, including the planetary emergency and things like pandemics. The second point is about how we can use digital solutions like AI to identify risks for tipping points, for climate tipping points, so that we're actually better at risk management and risk governance. The third point then is about how we use digital solutions to actually address our planetary emergency. So for example, we can utilize AI to have a better understanding about different scenario planning and identifying how systems interact and interrelate. And then fourthly, I've outlined the concept of the global index for the vital determinants of life that we've just heard about. Then going forward, we have a range of longer term recommendations, including creating a one planet health system that could be delivered as services, as global goods, developed through digital technology. That could be placed on a global platform for one planet health or for people and planet. Such a platform, in essence, we've created with the Platform for Planet, Place and People. You can see this initiative as a prototype for what's needed in the future. And lastly, we need to scale up a workforce for the future. So this slide gives the example of a governance framework for artificial intelligence. So this report has already informed a briefing on artificial intelligence and governance for the Interaction Council, one of the key partners of this initiative. In essence, we need to identify the key risks and place good governance mechanisms that match those risks in place. And we need to maximize the benefits of digital solutions and emerging technology as it comes forward and enhance capacity and leadership to achieve that. Our future ultimately will be dependent on the convergence of the digital revolution and the climate emergency. Going forward in the next 5 years, we'll see a critical interplay of the digital revolution with the coming online of quantum computing and artificial intelligence moving from narrow to general and more comprehensive forms that will create challenges as well as opportunities. The more that we can align these two big revolutions together in the next few years will be really instrumental on the survival of our species into the future. Ultimately, we need to take a quantum leap to a smart and wise, healthy and green future for all to survive. Digital technology can play a really key role going forward. In this slide, this is advanced by the Interaction Council as a key recommendation of how we strengthen our global governance mechanisms to address challenges like future pandemics and the planetary emergency, big threats to the existence of human survival. At the top, we need to strengthen overall governance. But the pillars you see, we already have many of the pillars, but they don't coordinate and cooperate as well as they could. And digital solutions could actually help transform that way of how we collaborate and how we coordinate, how we communicate fast, and how we innovate together. So they can play a really key role, and that in turn will help support global governance going forward. So going forward, we welcome engagement with more partners to take forward initiatives of creating global goods through digital solutions, whether it's the climate emergency or greater access to health and education. Do contact us, because we're looking for partnerships in other parts of the world that can take forward key priorities as part of the Platform for Planet, Place and People and the Commonwealth Centre for Digital Health. I'd like to say a big thank you to the Gamma team who've all presented here today. They've worked fantastically hard over the last year and had the biggest challenge, I hope, of their life, but a really important challenge to create a healthier planet for all. This builds on the great work from the Alpha team that set up the digital platform for Planet, Place and People in the first year, followed by the Beta team, which developed the 5-year plan, as well as a digital solutions for addressing pandemics and strengthening global health security. Next year, we'll await the next team, but we're also looking for new partnerships to set up new hubs in other parts of the world. So do get in touch and we'll welcome further engagement. Thank you so much. So a big thank you for everyone for your patience and interest in today's presentations and the launch of this new report on digital solutions for the climate crisis and planetary emergency. We'll be circulating the link to the report on this shortly, so you can see the further detail, and I welcome particularly any further feedback if there's areas that you'd like to discuss and explore further, but in particular those that would welcome joining in partnership on collaborative initiatives going forward. One of the key things is about that I'm looking for is about how do we strengthen global governance through digital platforms that could enable that in terms of addressing essentially existential threats and risks to humanity going forward. So not just from the climate and planetary emergency, from pandemics obviously as well, but also from the threats from digital technology and emerging technology as well. We can take common approaches to addressing many of our global challenges together. So a big thank you. I think we have a few comments in the chat, and I also want to welcome Professor Vajira to give any reflections as well. Thank you.
Thank you, Joe. I'd like to congratulate you and the team for the report, the link to which was just shared on the chat so that everybody could download the report. I'd like to acknowledge the presence of several leaders in the civil society space of the Commonwealth in the forum. We have Nicholas Watts, the chair of the IFCO, which is the Forum for Forum of Commonwealth Civil Society Organizations. I wonder, Nicholas, whether you have been a champion of the climate and a lot of other things. Nicholas, would you like to say a few words?
So whilst we're waiting for Nicholas, I just want to say, I know there's a few comments and questions that have come up in the chat. I hope I've addressed quite a lot of them as we've gone along in today's presentations. If you don't feel that I've sufficiently addressed them, please do get in touch, and I would welcome a sort of a further or longer discussion individually as well. That'd be most welcome. But I think one of the kind of very pertinent questions early on as well is, are we all doomed? And just to reflect, I think, you know, the prognosis from a medical perspective does not look good. And that's why, you know, why we've taken this action to apply essentially our medical knowledge as doctors to essentially a global challenge, and to try and contribute to solving that global challenge, not just from a health perspective, but also applying digital solutions. The other reflection I'd say from a medical perspective as well is that when a patient is in intensive care and in a critical state, they can be very close to death's door, but actually all the health staff work together non-stop around the hour to actually save patient planet. And actually all of us as doctors have known miraculous recoveries from those that are close to death's door. So my last comment will be to say, do not give up hope, but we need to work together if we are to save patient planet. Thank you.
Thank you, Joe. I think Nicholas, you've unmuted. You're ready to talk.
Thank you, Vajira. I've got on top of the technology. It was defeating me for a while, which is a problem if we're trying to engage with the digital world. I put a couple of points in the chat because one of my concerns is about irreversibility, and the other is persuading people that this is a real challenge. This isn't a challenge you can just shove on the back burner and forget about for a bit. So I think this is a wonderful initiative that you're pushing forward, but we have to get senior decision makers to stop acting in denial. The UK has just dropped off the sort of leadership board for climate change, which I think is disgraceful. And we've got people still arguing for fossil fuel. And you know, if we're going to take a digital approach, how do we get the information about which actors are, as it were, making most damage? Because obviously if you're working in intensive care, you would rather not have people stabbed and beaten up on the street to get into intensive care. And part of our political system seems to be actually exacerbating the conditions. So I'm more on the social science cultural side of looking at how we change attitudes, but how we bring home to people the realities, because people sit and look and they sit in forest fires and in floods, but the victims of the fires and the floods are not those making the decisions, and they're not the ones with the money to buy parts of sort of mountain areas in Latin America where they can move to in the vain expectation of escaping what's coming down the track. So how can we persuade people? And that's what I think the Commonwealth organizations should be working with you on, you know, how we get this message across. But thank you very much for today.
Thank you, Nicholas. Those are very valid points. And I think we need to have a longer discussion on how we overcome those. I would also like to invite some comments from Professor Jayalal from India, the Secretary General of the Commonwealth Medical Association. Prof. Jayalal is championing climate action with young people in India, and now taking it to the Commonwealth. Dr. Jayalal.
Yeah, thank you very much, Professor. And indeed, it was a very, very informative and quite useful presentations we could hear. The various digital options which you are providing and various digital solutions you are providing for the climate change resilience. I'm sure as Commonwealth, we always believe in equitable access and affordability of this digital solution made available to people across the country. It should not just stop short with the metropolitan cities or in the capitals of our country, but what we need and more effects such digital solutions reaching to the people in the rural parts of different areas. That I'm sure the affordability question comes as we have a plethora of solutions coming in, plethora of digital mark coming, and Commonwealth like this your forum or digital health forum should come out, standardize something, and put forth the valuable things to the people, or what is more important, more in a structured level. If you can give, it will be definitely a useful one. I think this is a war-like situation. It is a do-or-die situation now we are living. So every bit of contribution on that climate change or the climate resilience is going to be of a great benefit and great effort for us. So on that ground, and the efforts you are putting in at the Commonwealth level to make the digital health, which can brought us a common solution on the table where we can discuss and take whichever is necessary for our own country, is a great effort. So we totally agree with you. We also know that is a Commonwealth Medical Association as a doctors, as a healthcare institutions are also playing a major role in the production of or the contribution of the climate change. And we are now taking efforts to stimulate our doctors to see to that how best our hospitals can turn to the climate resilience on carbon banking and carbon funding and zero carbon balance hospitals, and how we are eliminating. So these are the options we are working on that. Definitely with all your digital health also, we will be able to contribute more to this. Thank you very much for this opportunity to listen to the very informative lectures offered today.
Thank you very much. Let's move on to Prof. Agnes, who has raised her hand.
Yes, thank you very much. And especially for this very instructive presentation. Africa has contributed the less to climate change and the trouble where our planet is, but we will suffer the most. And technology is not enough distributed on our continent to mitigate or solving the problem for Africans. And on top of that, we are not on the table where this is discussed at all level. Why we need also to contribute to the positive change by continuing our development without damaging more the planet, what is going to be difficult. So I propose that take us on the table for us to design our developments without increasing the problem, and also to think about what the problem will impact our development. Take us today, we are not enough represented. And when we will be represented, we will also have contributed to the damage if we don't change now. Thank you.
Thank you. Those are indeed very valuable comments and very valid comments. Yes, I think Prof. Dr. Joe Nurse wants to respond.
Thank you, Prof. Agnes, and do get in touch as well. We're currently in discussions with Commonwealth colleagues in Kenya who are hoping to develop an innovation week with the government, I think, of Kenya. And it's an area that I'm hoping, and I know I've had discussions with Prof. Vajira, that we can actually develop an African hub of this initiative going forward, so that we have African solutions and actually, the digital solutions can act as a flattening of inequalities, global inequalities, by creating them as global goods, but also by engaging all the regions of this world in terms of solution making. This should not just be an initiative that comes from the West. And that's why I've been so pleased that Sri Lanka has taken leadership in this initiative. So thank you.
Great, Dr. Joe, but there's something that you're in this, Africa is 54 countries. So don't consider only those who were formerly colonized by the British and the Commonwealth.
Yeah.
And they are not necessarily the most powerful or the most impacting the decision of the continent. So I propose to you to have a wider vision, and we have an African Union.
Yes.
We have a department in charge of that problem. Thank you. No, those are the people to tackle, not a portion of Africa.
No, I quite agree. And I think one of the kind of key things that we'd like to advance going forward is to make, essentially this can be a global good. It had its origins in the Commonwealth, but going forward, we see this as the creation of global goods, and we could be seeking a global platform, but with contributions from different regions. So, but well pointed out. So thank you.
I could help you for that.
I would love to. Do get in touch. Thank you.
Yes.
Thank you. And I wonder whether any other participants would like to make any comments. Please, if you raise your hand, I'll be happy to call your name out.
I know we've run over time already, so I think we're sort of an hour and 3/4. So I suspect a lot of people might be a bit tired, but we do welcome follow-up discussions on this, and we'll circulate the link as well through those networks that, where you got the invite in the first place. Oh, Nick. Nicholas Watts, you've got a
sorry, I can't find all the controls on my screen, but just one point I made in the chat was it would be wonderful if we could find a way of linking this up to citizen science more closely, and the way that the general public across the Commonwealth, or more widely if we take the points about Africa, but the whole notion of how the data that is produced by citizens every day can be included. But I'm sure that's within your thinking. It would just be nice to have it more.
That's a very valuable point, actually, Nicholas. And I was quite impressed to see that there were quite a few of the digital solutions fell in that category. And ultimately, if we create a global platform, there should be a component of that that's sort of about engaging, different partners, whether they're academia, different countries, civil society, or the general public, in terms of, sort of creating solutions. Ultimately, this is such a big global problem. We all need to be involved. And going forward, digital solutions and platforms could enable us to do that. And it's about ultimately shaping that future and trying to reduce the potential risks and harms that have already been highlighted. So thanks.
Thanks, Joe. Could I just highlight, Kenneth Stokes has just put in the chat, why not consider a series of regional citizen science hackathons? So that's another piece of momentum for this.
Okay, Ken, I'll follow up with you on that. That sounds a good idea. Thank you.
Thank you, everybody. Then so we've like 17 minutes over time now. So thank you very much for your participation. It's great to see all of you, and I hope you will continue to engage the work that we are doing, and support the work, and also more importantly, I think help us take the work to other parts of not only the Commonwealth but beyond. As Prof. Agnes mentioned, I mean, we are all global citizens, and we can be part of what we do. We should make impacts everywhere. So and even the Commonwealth itself now is moving beyond the former British countries to,
so it should.
and it's becoming more inclusive with more non-former British countries coming into the Commonwealth. So therefore, it's not restrictive. We want to be inclusive, and we want to, make sure that the work that we do has impacts everywhere. So with those words, thank you very much for your, to all of you for your participation. I'd like to once again, as a chair, congratulate Dr. Jonas and our Gamma team of Digital Health Fellows for all the wonderful work that they have done with this report. And I'd like to acknowledge the two teams before them, the Alpha team and the Beta team, who laid the foundation for the work that they have done. And also say that we are looking forward to the next team, which will be taking over in August, September, to take the work forward. And we look forward to a event in another year's time to showcase the work that they do. So with those words, thank you very much, everyone. Take care and all the very best. Thank you.
Thank you, everyone. Thank you.
Thank you.